Factoring quadratic polynomial ax squared plus bx plus c, where a is not equal 1, it might not be as simple as factoring the quadratic polynomial with a equal 1, but the technique shown here will work if we want to factor the polynomial over the integers. What that means that we are assuming that a, b, c, as well as any coefficients of resulting factors are integers. Let's look at an example and illustrate how we can factor that polynomial. So let's follow the steps indicated above. Our polynomial is negative 6z squared plus z plus 1. Variable is z. The coefficient a is negative 6. The b is 1 and c is 1. We are looking for two numbers p and q such that p times q is a times c, which is negative 6, and the p plus q is equal b, which is 1. Those numbers are p should be 3 and the q should be negative 2. With that in mind, we'll rewrite our polynomial negative 3z squared plus z plus 1 as negative 6z squared, and the middle term is z. This is our b, and b is p plus q, so this is, we can write it as a plus 3z's minus 2z's, and plus 1, right? Plus z plus 1. Now we'll factor this polynomial by grouping. So we form two groups. From each group we factor common factors if there are any, and see what we'll have. So from the first group we'll factor negative 3z. What will be left is 2z plus 1. 2z minus 1, I'm sorry, minus 1, since we are factoring negative 3z. From the second group we factor negative 1, and we'll have 2z's minus 1. As you can see, there are two common factors in both terms, so we factor it out. 2z minus 1. And what will be left is negative 3z minus 1. The polynomial is to be factored completely, and from the second factor, negative 3z minus 1, we can factor negative 1, giving us 3z plus 1, and therefore as a result we'll have negative 2z minus 1 times 3z plus 1.